And so now I'm going to run the carbon NMR. I'm currently in the proton NMR setting. I need to change it to carbon NMR. The command for that is NU space C-13, and then I hit enter. Now I'm in the carbon NMR setting. And our NMR's magnet has our carbon 13 absorbing 15 megahertz, not 60 megahertz. Protons absorb at 60 megahertz, our carbon's at 15 megahertz. Same magnetic fields, just those isotopes absorb different radio waves at different, same magnetic field. And now to run my sample, I do the same thing as before. I type the command ZG, and it shows up down here next to the carbon 13 prompt. And then I hit enter. It asks me to use the default name, and I want to, so I hit enter again. And now it's going to start doing the scans. And proton NMR, it was just taking a single scan because our proton NMR is so abundant. But for carbon NMR, we're doing more because the carbon 13 isotope's only about 1% abundant. So we're doing more scans. We're going to do 12 total. Yeah, we're at 3 of 12 scans. We'll let it do all 12. And if it turns out well, I'll just keep this Spectra. We'll be done with this NMR. If I'm missing a lot of the carbon signals because it's too dilute a sample, I might evaporate some of the methylene chloride or deuterated chloroform and get this to be a better signal. So while we're waiting for those scans, let's talk about the Spectra. So I have, looks like we have o-Toluic acid, right? So how many carbon signals should we have? We should have the carbonyl signal around like 180, 175. Aromatic, all the aromatics are unique. So 6 in the aromatic region, like 100 to 150. And then the methyl is at about 25, 30 or so. So let's see, how many is that total? 6, 7, 8. So I'm hoping we get all 8 carbon signals. Let's see. So it's done collecting the data. I can click OK. And when I go to nuts, you would think I would type A2 to bring it over like proton NMR, but we don't. It's a little different for carbon NMR. We type the command, we type control, hold control, the control button I hold, and then the F3 key up here. When I do that, it asks which data do you want to open? I want to open the last default name saved data there. So OK. And then it's going to ask me for this line broadening. We go 0.5 for the line broadening. And OK. And then here's our Spectra. What do you think? It's got a lot going on here. It's because the minimum peak height's set too low. I'm using the wheel to lower this peaks down. If I press and hold, I got this horizontal line again. Press and hold that and type M. It'll only label the signals above that line. It's a little clearer to see. And currently, I'm seeing 5 signals. Shoot, I'm on 8. I think this one might be the carbonyl. Let me see if I can just get that carbonyl, if it'll give me the right number. Let's see if I type M again. That gets me 9. Yeah, there's kind of a lot going on here. Let's zoom in on this aromatic. I should see 6 aromatic signals. I'm seeing 1, 2, 3, 4, 5 maybe. So I'm going to try one thing before I make my sample more concentrated. I'm going to go back and I'm going to rescan, but this time I'll do more than 12 scans. Last time I did 12 scans, right? Let me try changing that. I'm going to type the letter N and S, number of scans. I hit S. So NS, see it down there? NS, and then I hit enter. It asks me how many do I want it to be. I'm going to try, let's go 30. Try 30. Say OK to that, and it'll start scanning carbon NMR again. Oh no, not yet actually. It's set up to do 30 instead of 12, but it's not going to start until I type ZG enter enter. And here we go, running the broadband decoupling. The broadband decoupling refers to the fact that we decouple the proton NMRs. While that's running, I'm going to go look at my NMR test tube that I was using to prepare the sample. Yeah, it's got a lot of deuterated chloroform in it still, huh? Let's can try to evaporate this by blowing nitrogen gas into it. I'm the rich man's way to do it. I think I might do that. Let's just walk it over then. Yeah, I'll start doing it. Okay, back out of our nitrogen tank. Remember, this gauge is closer to the tank. That tells you the pressure that's in the tank when it's open to the tank. It's currently not open to the tank, it's closed, but it's still showing pressure because there's a little bit of pressure in the gauge. And I'll get rid of it to show you what I mean. But this gauge further from the tank tells me how much I'm allowing out. So to allow that gas, a little bit of gas that's stored in here out, I twist this clockwise and you'll see it'll go down that first gauge. Yeah. So it is off. So when I want to turn the thing on, I make sure this is clockwise to the point where it's loose. That means it's not going to let anything out when I open the tank. So I'll open the tank, and look at that. I've got about, lighting's not good here. I've got about 1,100 pounds per square inch, about a little under 8,000 kilopascals of pressure of nitrogen gas. A lot, huh? I'm letting out nothing. If I twist this brass knob clockwise, eventually it'll start coming out. Gas will start coming out, and the pressure that I let out will be read off that second gauge. See if I go fast enough. Okay, so I'm going to use that. I'm going to blow it into my test tube. I was able to evaporate a lot of it in only about a minute of blowing it with nitrogen gas, and so now it's got a lot of solid on the side walls of it, and just a little bit of deuterated chloroform in there. And while I was doing that, I ran the first dilute sample for 30 scans instead of 12, and it did come out better. I got 7 of the 8 signals. It's looking pretty good. I don't like that I have both the table and these peak labels, so I'm going to take away the peak labels. View, peak labels, go away. Okay, so I got 7 out of the 8 that I want, but I want them all. Let me zoom in on these though, just to show you what we got so far. So it looks like I have the 1 here, that's probably the carbonyl, and then I've got another 1, 2, 3, 4, 5. I think I only have 5 aromatics. Yeah, 1, 2, 3, 4, 5. I should have 6 aromatics, and then the methyl. So I'm missing 1 aromatic. It must be one of the, my guess is the aromatic I'm missing is either this one or that one, because they have no hydrogens. They tend to be the shortest signals. I'm going to print this up. I'm going to save it, but then I'm going to eject this NMR tube, pour it into that same test tube that I was evaporating the solvent from before, evaporate some more, and then add a little deuterated DMSO to get it even. I'm going to get it to the point where it's insoluble. There's a lot of undissolved solid in there. Add a couple drops of deuterated DMSO, get it nice and concentrated, and then we'll get all the carbon signals, is my prediction. So I'll eject again to get this out. Put a chem wipe over the probe tube and hit eject. Got it. There it is. And I will get it out. I can maybe do it with the camera on. Nah, I'm going to turn the camera off to get this part. I removed the cap from my NMR tube, and I'm going to pour this NMR tube into the test tube that I was evaporating from just now. So now I've got basically almost all of my sample back in here. I'm going to still use this same test tube, so I don't mind having a little residual in there. And I will take this over to the nitro tank again and evaporate some more. Okay, I have the sample evaporated down below that 0.5 centimeter line. That's good. And I got a lot of solid here. I'm going to try to pipette some of this up and then put it down the side, see if it'll help. Doesn't seem to do much. It looks like this is really oversaturated right now, which is what I wanted. What I'll try is to help dissolve it with the expensive stuff, the deuterated DMSO good stuff. I'll draw some of this up, put it back in, draw it up, put it back in. Okay, so now don't want to use too much, just enough. I'm going to do it drop-wise. I'll do like maybe 1, you can't see, huh? 2, 3 drops. Let's see what that does. I think it might be helping a little bit. I'm going to do a little more. 1, 2, 3 more drops. Oh yeah, where the drops went down, it dissolved the solid. So that's a good sign. Okay, yeah, this is going to be much better. Switch this over. I'll let it draw up. Push this down. Yep, looks like it's working good, huh? Yeah, now we're getting there. Is it dissolving? Looks like it is. Another thing about deuterated DMSO, it dissolves things very well, organics very well, and it also it's kind of slow to dissolve them sometimes. So other solvents, if something's soluble in them, they just dissolve right away. But with deuterated DMSO, occasionally it'll like take a little while for it to dissolve. You have to give it a minute, and it'll dissolve more than you expected after a minute or so of giving it time. So this was effective. I only had to add 6 drops of deuterated DMSO. I didn't have to add like the whole ½ centimeter worth. And now I will add it back to my NMR tube. And when I do it, I actually like to get a little bit of solid into the NMR tube, if it's possible. I don't mind a little bit of undissolved solid in the NMR tube, actually is fine. And it lets you know that you're saturated. Ooh, that was over the 4 centimeters. Let's see how I've got a fair amount of undissolved solid. That's not too bad, actually. That's going to be just fine. And if I want to really go to the next level, I can heat this just very briefly with a blow dryer. But you have to be careful. If you heat it up too much, this cap will pop off on you. So you always got to wear your safety goggles and be careful with it. But I believe that this alone is going to be good enough. It's going to give me all my carbon signals. That's my guess. Now to get the more concentrated deuterated chloroform, deuterated DMSO sample in the NMR, adjust the height, let it float, press the off button, watch it sink, press the on button, and watch it spin. Looking good. Okay, close the lid carefully. And then let's run it. I'll go to the AII NMR software, and you'd think I just go right and run the carbon first, but I won't. I need to run the proton NMR first because I need to check to make sure if the TMS is still at 0, and to shim it if it needs it. This is a new sample really because of the more concentrated new solvents, so it's probably going to need to shim. So I want to switch to the proton NMR setting, and it's as simple as typing NU space H1 and then enter. Now we're in the proton NMR, and I'll rescan to check to see if I'm right, if I need to ZG enter. I'm checking to see if I really do need to set TMS back to 0, and if I need to shim, which I think I will. Okay, FID's up, it's done. Bring it over to nuts. Bring over proton scans with A2. There it is. Yeah, it's looking, oh, the baseline looks so much better. Remember before the baseline was a lot more jaggedy because it was dilute? Now it looks nice. This is a better sample. And my TMS signal is lower relative to my sample signals because the sample is more concentrated. TMS is no longer at 0. So where is it now? If I click left click hold and type M, I'm at 0.149. So let's fix that first. Actually, I'll shim first. It doesn't matter. I'll do that. I'll do the frequency offset first. Frequency offset. Enter. 0.149. Okay. 0 is where I want TMS. Okay, so that's fixed. Now I'll type shim. S-H-I-M. Enter. Relaxation delay 2 seconds. Enter. And I'll wait for it to shim. And then when I get this proton NMR after the shim and everything, I don't think I need to print it or save it because I have a nice proton NMR from the dilute sample. I'm just going to go. I'm just using this proton NMR as a diagnostic. It's shimming the Y and C electromagnets, so it's adjusting the magnetic field around the sample to make it as homogeneous as possible. Okay, the shimming is done. So I'll rescan ZG. I want to see that my TMS got moved over. Enter. Enter. I want to see that my TMS got moved over and that the shims look better. Shims were pretty good, but might as well make it look even better. Okay, that's done. And then nuts, I type A2. Ooh. Zoomed in a lot. Okay, it's looking pretty good. TMS is it's not exactly 0. It shifted a bit, huh? It's at 0.036, negative 0.036. It's close enough, but you know what? I could still fix it. And the rest of this looks good. Yeah. What I'll do is I'll do the TMS. We'll fix again. Frequency offset enter. It's at negative. You gotta remember the negative 0.036. Enter, and it should be a 0. Enter. So I don't have to rescan it. I just fixed it one last time. Now I'm gonna run my carbon NMR. So I type NU space C13. Enter, and then and it's in the carbon setting now. You can see it. Now I will scan it. ZG, enter. And I'm just doing the default 12 scans. I'm thinking that that'll be enough, that I'll be able to see all 8 carbon signals. I'll be able to see the carbonyl about 175, the methyl 2530, and then the 6 aromatics from 150 to 100-ish. It's scanning it now. It's at 4 out of 12, and if we're curious, while it's still scanning, we can go look and see what our progress looks like. So I'm not in the base level, I'm in zoom. I'm going to hit enter, and then to bring over the current number of carbon scans, let's see where we're at. We're at 7 now. So maybe it'll be 8 by the time I do this, but to bring it over, I'll go Control F3, enter, 0.5, enter. Okay, see how it looks. So this is 7 or 8 scans. Oh, I think we got them all already. Yes, 8. So we see carbonyl. We see this. I think this is the one we were missing before. 1, 2, 3, 4, 5, 6, 7. Zoom in on that aromatic region. Yeah, see the aromatics here. 1, 2, 3, 4, 5, and that 6. 1, 2, 3, 4, 5, 6 aromatics. All right, that was just 7 scans. Oh, now we got 12. It's done. So let's bring over all 12. I'm not in the base level. I need to hit enter to get into the base level, and then Control F3. It's asking me to open the default name. Yes, I hit enter for that, and then it's asking line broadening. That's the 0.5. Enter. Click OK. And it looks really nice. Look at that. Yep. Oh, we got 9 now. What's the 9th one? 1, 2, 3, 4, 5, 6, 7, 8. Oh, they're counting this as 2. Let me look at that again. Oh, it's getting confused. It's counting this reverse peak for some reason. We spent all this time to make this nice. I'm going to do a phasing. This is something you would normally do, but I highlight one area, type the letter 1. I highlight this area, I type the letter 2, and then I get out of the zoom, I type the letter PE, and then I can phase. This side looks good. This is the side I want to fix. Scroll down like that. Over here, yeah, that looks good. I think that'll help. Let's do a minimum peak height again. So I just phased the spectrum. That's not something you normally do, but I want it to look nice since it's our. It looks really nice. It could look a little better with more scans though, huh? And we took the whole time to evaporate the sample and everything. Let's do more scans. Let's do this. NS space, we'll do 24. Enter. ZG, enter. And I'll pause the video and I'll come back when it's done with all 24 scans. Here's what it looks like after 24 scans. Very nice. Got all 8 signals. We see the carbonyl down here, nice and clean. We see the 6 aromatics. I'll zoom in to see them. 1, 2, 3, 4, 5, 6. These 2 small ones, of course, are the quaternary carbons. And our methyl, nice and strong. Looks awesome. We don't see the TMS because remember the TMS is dilute in this solution. It's 1%. It's probably a little less than 1%. And of that 1% TMS, only 1% of that has carbon 13. So that's okay. And I'll label this one and save it for you guys. This is one I'll have you guys put the structure on and label. That's so nice. Oh, one other thing I was going to say. We definitely have orthotoluic acid because if we had benzoic acid, it would only have 1, 2, 3, 4, 5 carbon signals because it's symmetric. It would have 5 total carbon signals where the orthotoluic has 8. So yep, we have orthotoluic acid.